If you walk inside a boiler room with two or more older Category 1 boilers, you will most likely see a barometric or two installed in the flue. They are installed at different locations in every boiler room. Today, we're going to talk about where a barometric damper belongs, why putting it in the wrong place causes problems, as well as the pros and cons of each location. Welcome to Boiler Room Detective. I'm your host, Ray Wolfart. My 14 boiler books are available at T.F. Campbell, Pronto Heating Supplies, Amazon, and heatinghelp.com. Okay, detectives, what is a barometric damper and what does it do? Also called a draft regulator, it's a simple but crucial device in oil or gas-fired boilers that helps control the draft. That's the flow of air pulling flue gases up the chimney. It looks like a round door on a T in the flue pipe with an adjustable weight. When the chimney draft gets too strong from wind, temperature changes, or barometric pressure shifts, the damper swings open to let room air into the flue. This dilutes the hot gases, slows down the pull, and keeps the boiler's combustion efficient without wasting heat. Think of it like a pressure relief valve for your chimney. It maintains a steady negative pressure, usually about negative 2/100 to negative 5/100 inch water column, to ensure safe and optimal operation. Be sure the barometric damper is level and plumb. Where should it be installed and how many do we need? The following are the locations Field Controls recommends. Draft controls are recommended on gas systems where the chimney is over 30 feet high. Gas-only systems require a double-acting barometric damper, and fuel oil requires a single-acting. If you are firing with gas only, the red stops on the barometric damper should be removed. They are used strictly for fuel oil. You want to hear something weird? Gas-only barometric dampers are double-acting to allow outward opening for block flues or downdrafts. You always pair with spill switches on gas setups for safety, as codes dictate. Always size the damper to match the flue diameter. Too small and the draft is too high. Too big and it's wasteful and hard to control. Fields recommends one barometric damper on each boiler. That's its A position. It allows individual draft control. A common mistake I see is the barometric installed directly on the boiler flue outlet. If it's too close to the boiler flue outlet, you will have flue gas spillage if firing into a cool chimney until the chimney warms. It should be installed at least 18 to 24 inches above the boiler flue outlet in a straight piece of pipe. The next recommended location, B, is on the horizontal flue between each boiler. This again allows individual controls, but might be a little more difficult to reach. If you notice, the individual barometric controls are not the same size as the flue. They are the same size as the one on each boiler and installed near the bottom of the horizontal flue pipe. The last location, C, is the common location I have seen in my career. I prefer it as there's less adjustment for one barometric damper than for three, and it seems to work fairly well. Field Controls and others strongly recommend individual dampers, C, A, and B, for best balancing, especially if boilers have different firing rates or chimney pulls. Individual barometrics are ideal for precise control and avoiding imbalances, but a single well-placed one in the main breeching is a practical compromise. Now let's talk about where not to install a barometric. For years, we saw the barometric damper installed at the far end of the flue. This is problematic as the velocity through the horizontal flue pipe is increased. This causes a lower flue pressure. It creates a venturi effect in the flue pipe, pulling the flue gases prematurely through the boiler. Placing it at the far end allows uncontrolled draft velocity and pressure differences that can overdraft the boiler, pull the flame and heat out of the boiler, increase standby losses, and destabilize combustion. Look at this project we consulted on. We were called in because of the elevated carbon monoxide levels in the boiler room. The boiler had a barometric damper on the outlet, and just past it was a manual damper. The manual damper closed, spilling flue gases into the room. It was a legal nightmare as one of the employees was exposed to carbon monoxide and had to be taken to the hospital. All boiler rooms should have a carbon monoxide detector inside. Always consult local codes and a licensed pro for installations. And subscribe for more boiler tips. Drop your boiler questions below. This is Ray Wolfarth, the Boiler Room Detective.